Hello, our fabulous chemistry minions.
And our not so fabulous ones too.
To all y'all,
Hello, everybody.
Milk's here.
And the MoNaCo too.
We almost done. Thanks for bearing with that last long one.
Yeah, it's just what's right.
It is, we need to get through it. And now we're going to tackle what's called isomers.
So isomers and isotopes have the same kind of root word. Iso means same but different.
Right.
Okay? So isomers are to organic compounds as isotopes are to atoms because isomers have the same number of each atom, but a different way of putting them together. I hope you're seeing in your practice that there might be more than one way to skin a cat.
Right. Molecules will have the same chemical formula, but they will have different names and properties because they are arranged differently.
Yes.
And if you think about it, we talked a lot at the beginning of the unit about there's just billions and billions and billions of possibilities to create these carbon molecules because they make four bonds.
Mm-hmm.
And some of them, guess what? They're going to have the same number of carbons and hydrogens, but
different way of connecting the pieces.
these are those ones that
This
overlap.
is like the Lego kit that you could make a castle out of if you followed the instructions, but everybody knows you could smash the pieces and make a boat too.
Right.
You know, so isomers are like that.
Right. And we're going to keep it simple with these isomers. I notice no double bonds.
No bond. So there's good old butane,
Yep.
4 carbon long in the chain.
Ane, single bonded.
Yep. How are we going to make an isomer out of this?
Well, I'm going to give you a hint. Single bonds, the easiest thing to do is take a terminal carbon off,
Right?
stick it somewhere on what's left of the carbon chain.
Oh, so you mean to make a branch?
Right.
Take a carbon off the end of the chain.
Yep.
And slap it somewhere in the middle of the chain.
Yeah, why don't you go ahead and
So that it's a branch. So we're going to take
this guy, take off that methyl, and let me get an arrow up to that second carbon. Done. That's what we're going to do. We're going to put him there, and then the H will come over where the methyl was.
Right.
So let's redraw that.
Let's see. So this is going to be only
3 carbons long. 1, 2, 3. Now I'm going to have a carbon side chain on the middle carbon. Fill in my H's.
Now we count our.
Now let's count the H's to make sure they're all the right. We have the same number.
Yep. So I got C4H10.
H10, and now we are good. Notice the
Oh, they're the same.
molecular formula is the same, like Mr. Milks and Mr. MoNaCo said they would be. But now the name is different. I have a 3 carbon backbone now. So instead of butane, I am now propane. I have a methyl group on the second carbon, so I'm going to say 2-methyl in front. The 2 telling me where the methyl is, the methyl telling me that it's a 1 carbon long side chain. So notice now the names are different. These things are isomers. Same numbers of carbons and hydrogens, different chemical arrangement. So single bond, easiest thing to do, take off the end carbon and stick it on the side chain somewhere.
Mm-hmm.
Or stick it on the new carbon chain.
And so now you see, if you're just looking at the formulas, you think we're talking about the same exact stuff. But
C4H10.
you got to put it together, and you see that it's really not.
Right, so this is where the name of that thing comes in so important, shows us how to draw it.
So we're going to throw a few isomers of pentane at you.
Okay?
There's good old-fashioned pentane to start with.
All right, so the first thing to do, let's take that end carbon off, and let's give it a side chain. Perfect.
Cool. So
4 carbons long now is a but, and it's an ane because it's single bonded, and then I'm going to stick a carbon on there somewhere.
So I put it on this one, it looks like.
Perfect. Count up my total H's.
3, 6, 9, 10, 11, 12.
12, C, 5, H, 12. Notice the molecular formula is the same, and then we just got to finish naming it. I have a methyl group on what would be the second carbon, not the third. We got to go with the lowest number it could be. So it's 2-methyl butane. Remember, the 2 tells me which carbon it is. Doesn't tell me that there's 2 methyls. That would be dimethyl. We're going to go 2-methyl butane. Now, if we're going to make another isomer out of this, I'm going to say do the same thing. Cut off a terminal carbon. And
put this one on here.
so let's take the one from the other side. There you go. Because we don't want to. What you don't want to do is come up and make another straight chain. And just because they're bent doesn't mean they're not a straight chain.
And just because I drew it this way doesn't mean that if you draw it the other way, it's not identical.
True, if you were to flip the thing around and put the
Uh-huh.
carbon on what you would have as the 3-2 instead of the 2-3. So now I have 3 carbons down the middle. I have a carbon on top. I have a carbon on the bottom. So I still have 5 carbons. Let's count up our H's.
3, 6, 9, 12.
Okay, so that's good. That checks. We have the same number of carbons and hydrogens.
Now we got to find our longest chain.
Right, so whether you count up or down, you're still going to get 3. So now we're talking propane.
And or backwards or forward, you're still going to get
3,
3.
and look at that center carbon, still going to be a 2.
Right.
So we're going to call it propane. And then I have 2 methyls on the second carbon. So we're going to call that 2,2-dimethyl. Telling me that there's 2 methyls, each of them on the second carbon.
And I was teaching a student this today, and I came across the reason why we go 2,2-dimethyl. I wanted to point this out. So this is like 2-methyl, 2-methyl propane.
Correct.
Because
Now that's where we get the 2,2-dimethyl.
second carbon, there's a methyl. Second carbon's there a methyl. Why repeat myself? So I say 2, 2 dimethyl propane. Okay. So let's see what else we got. We got some isomers of hexane going down here. Hexane, 6 carbons long, and C6H14. That's straight hexane. Let's look and see. Let's make some branches. See what we can do.
First thing, let's take that terminal carbon off, and
We
let's
got a couple
hook them
places we
on in a few different places.
We got a few different places we can do it. So first thing, we're going to jump 1 carbon.
Let's put them on carbon 2 and then on carbon 3.
There. Okay. So
5 carbon chain is what I'm left with. Let's put a methyl on the second carbon. Good. Now the trick with these guys is when we go on to the next one, let's take the other variation of this particular one that we just made.
C6H14.
All right, good. So now we just got to name it. 5 carbon single bonded is a pentane. Thank you for numbering them to the right because we're going to start where that methyl is.
Right.
So now I got 2, I have a methyl on the second carbon. 2-methyl
Methyl.
pentane.
Pentane. Now I can also see here that since this chain is long enough, if I put it, I could also put that methyl group on the third carbon.
Correct. So let's go ahead and do that one right away because that's what I'm saying. By follow the trend you already started. So it helps with the possibilities of not getting confused and all of a sudden you're looking back trying to say, oh, what else could I make? So let's just do this one now. So now again, C6H14. We have the same molecular structure. I have the same 5 carbon backbone, so I'm going to be pentane. But this time my single methyl is on number 3 carbon, so this is called 3-methyl pentane.
3-methyl.
Now, you can pick whichever isomer we made. I don't care if you pick the one on the top or the one that we just drew, but let's take a terminal carbon off of it.
And slap it into the chain.
Somewhere else.
So, all right, I'm going to just draw this and go from here.
Okay. So now we should have a 4 carbon with the methyl on the 2. And where are we going to put our new methyl? How about on the 2? Perfect. Fill us up with hydrogen. This is going to give us our C5H14.
C6.
That's right, my bad. C6H14. Now I don't have a pentane anymore, I have a butane. Numbering it from the left, so my methyls are the lowest number. And I have 2 of them. So it's 2,2-dimethyl butane.
Number 2,2-dimethyl. And I strongly encourage you to be a little neater than I am and try and squeeze your pictures in the boxes.
Yeah.
And live and learn. I know I got to give you a little more space next time.
Right.
So we'll do.
So now if I'm looking at this particular one, I could take those 2 methyls. How about we put one on the second carbon and one on the third carbon? We'll still be a dimethyl, but let's change which numbers our carbons are on.
So we'll go like this.
There's my bute backbone. There's my two methyls, one on the second carbon, one on the third carbon, and the name is simply going to change now to 2,3-dimethylbutane. We'll again have 6 carbons, 14 hydrogens, sticking with our model of the same molecular formula, different structure.
Now,
The fifth one,
well, can you figure out the fifth isomer of hexane, or C6H14? Because I got to be honest.
how about stump your teacher? And it will be a teachable moment, because
Oh,
if
yeah.
I can prove to you
Oh, yeah.
that what you wrote down is the same as something that's already wrote down, you're going to learn a little bit of something.
We got these whiteboards to play with, so
Yes, let's make use
let's
of it.
use them.
So to sum this all up, first of all, I'm not writing anything. You're writing what we say.
Right.
Okay. First of all, an isomer is same chemical formula,
Different structure
but different arrangement.
and different name.
So that's different name, different properties.
So same formula, different name, different structure, different properties.
Right. So before we even get into single bonds, double bonds, I'm going to tell you, if I'm single bonded, I cannot add a double or a triple bond to make an isomer.
Because that would make it unsaturated and change the number of hydrogens involved.
There you go.
And it wouldn't have the same formula, so therefore it's not an isomer.
Correct. So if I'm single bonded, let's take an N carbon off and make a side chain. Easiest way to make an isomer.
Break off the end, create a branch.
There you go. Now, if you have a double bond or a triple bond in your straight chain anywhere, the easiest way to make an isomer,
To move it,
move the double bond itself.
as long as you don't move it to a point where the molecule's really just a mirror image of itself.
Yeah, just rotate it. You can't do that. So
That's really
the
only going to
propes
start
doesn't work.
happening in
After
pents and
butes.
hex.
Even buttes.
Bute, you can do it
You
too.
do
yeah.
1 bute, 2 bute. But
So-
with the propes, it's really just the same thing spun around.
So if you have a double or triple bond and the chain is long enough, feel free to move that double or triple bond around and you got yourself an isomer.
There you go. And after that, you're going to have to start taking out the terminal carbons and making side chains.
Right. But
That's the game.
any way you can connect those carbons and hydrogens that you're given in the problem so that they all have the correct number of bonds will get you an isomer.
There you go.
We just told you how to make branches and move double and triple bonds, but there are other ways for bigger, more complex molecules.
Thanks for listening.
Thank you.
Oh, yeah, summary page. There you go. This is what you're able to do now.
Yay.
Just like before, though. Do it tomorrow.